Right, so the hardest part about this question is, where do I start? How do I change this code that uses iteration, a standard for loop, very simple, just one line of code. How do I change this into a recursive procedure? So the structure of the recursive procedure will look something like this. Function SI, just for quickness I've just typed SI, given its name, rather than sequence item. Same format as a parameter. We know what the function does. What we're doing is replacing the loop. So if we get rid of lines 3 and 5, we're rewriting the loop using recursion. The only thing the function did was to increment a value. Answer became answer plus 1. So if we think of the function with the parameter n, if the function is defined in terms of itself, so SI is appearing within the function itself, and I do n plus 1, that's a logical start. Will that work? We know from the trace table, when there's a value n, we can find an answer. We can see how it works. So if n is 5, the answer was 16. If n is 1, the answer is 2. If n is, you see I'm actually circling I here, but I was talking about n. If we look at the code, n is used to set the upper limit for the loop. In other words, how many times the program's repeated. So this whole program had just two variables, n and answer. N, the number of times the program looped, the number of times something was done. So if we take n being 1, 2, 3, 4, 5, its output with 1 was the value 2. So 1 maps to 2, 2 maps to 4, 3 maps to 7, and 4 maps to 11, and 5 maps to 16. So I know if I call function sequence item with the value 1, I should get an output of 2, and so on. Now if I've entered this, if I used 1 there for that parameter, as this kind of skeleton here, we're thinking this, the whole principle of recursion is the function's called again here. It's called in again here, the function's calling itself, it's going to execute down to here, and when this function's finished, it returns back to there, and then that continues executing. So here I'm showing the kind of structure of a two-level recursive procedure. Now, if we follow this through, are we along the right lines? If we added the parameter to be 1, 1 plus 1 is 2, we call the function with the value 2. So the function, when called n equals 2, would produce an answer 4. And actually we need some kind of control, because we're just going to call the function again here, we're going to call another version, so on and so on and so on. So normally in a recursive function there's an if structure, a selection structure to control the execution. So here's our improved version. Now we're thinking, if I've got a control loop, I can say when n equals 1, I'll return the answer 2. So the control loop, the if statement, sets answer to be equal to 2. It then jumps down to here. Now this doesn't look good, because after the if structure here, we're going to set answer to be equal to n. Well, we don't want answer to be equal to n. We don't want this, because every time the procedure's called, n's going to change, so answer's going to change. We want to be able to control how that's changed. We've learnt that from the first version, so we need to get rid of these. Right, so I've got rid of that code that we had down the bottom here, answer being set equal to n. The reason why we had that n was we knew that this procedure only takes one parameter called n, and we want to return a variable called answer. So at some point in this recursive procedure we had to give answer its value. So you can see here at the moment answer's not being given a value in this lower part of the if structure. But let's have a look how this code works now. So we're happy that if n is given the value of 1, this Boolean expression is true, then answer becomes 2. The control structure, the selection structure, means the program then jumps down after the end if, so this function returns the value answer. Answer's been set equal to 2, so this is good. If n is 1, it returns 2, and it only needs to be called once. There is no need to recall this procedure recursively. Now let's take the situation where n is 2. Okay, so if n is 2, the Boolean expression is false. So we jump down to here. So do we think this is right? So now 2 would be added to 1. The function would be called again, effectively with n being 3. Is n equals to 3? No, this is false, so the function's being called again. I don't know why my 3 keeps disappearing, but never mind. The function's called again. This time now you can see we're going to get in an infinite loop here. Something's dramatically wrong here. There's nothing to stop the function keep calling level after level after level. Now, this is because the principle of how recursion works. One call calling another example of the function, another example, and so on. And when we get to the end of an execution, the spring uncoils. You go back to following the path in the reverse direction. But we must get to an end condition. So a basic principle of programming, all loops have to have an exit condition. How are we going to get out of this? The structure is very simple. We are only incrementing a value, but we chose to use a simple plus I, adding n to answer to increase it, so we move through a loop structure iteration. If we're using the plus operator here, we're continually increasing the value of n, and that will just keep building up and up. We've written an exit condition. If n equals 1, answers 2. That's the lowest level. So when we get down to answer being, when n equals 1, answers 2. If we think of this the other way round, rather than a loop building up, for I equals 1, something happens. Next I, move up, something happens. Recursively, we kind of need to think backwards. So let's think the worst case. When it's got to the highest level, when I equals 5, or n equals 5, whichever way you want to look at it, when your parameters got to 5, you output 16. If it's not 5, if the value's lower 4, you output 11. We've got a control already put in for n equals 1 to output 2. So if we, it's not intuitive, but if we change this plus to a minus, let's see what happens. Right, so I've changed the code now. We've changed this to a minus. So effectively, what we've got now, let's take the example of n being 2. That's the easiest example to work through. We know we want to get an output of 4. So let's see if that happens. So n equals 2. Our special case Boolean expression, the if statement there, n doesn't equal 1, this is false, so this is ignored. We jump down to the else. The next thing that happens here, The function's called again. This is the recursive part, but now we're saying take n and minus 1. So the function's called again with the value 1. With 1, there's a special case, so we know we're going to get to the end. We know we're going to not going to get stuck in an infinite loop. Now we're calling the function with 1. It stops. Answer set equal to 2 and returns. Now what we've got to start thinking about is we're writing a function, and one of the principles of a function is when it's called, the call is replaced by the value the function returns. So in other words, from here, this actually becomes the value 2, because this function was called with n equals 1. N equals 1 answers 2, return answer. So this code here would become the number 2. Excuse me. Now we're not finished. We're not finished when we call the function with a 2. We want to get the answer 4. At the moment we're getting the answer 2 because we're calling the function with the parameter 2. That's not true. We're coming down to here. We're going to a second level of recursion. We've now worked out we should be using minus, not plus, because using minus we will get to an end point. We will achieve, no matter what we start the function with, it will at some point end up where n does equal 1. So we need an exit condition. So we've solved the problem of the loop having an exit condition. But there's still a problem. If now we run this, n equals 1, answer becomes 2. We jump down to the end of the if statement, return answer. Good. This is finished with. This is now replaced with the value 2. So this expression becomes 2. What does the function do now? It returns answer. So answer's 2. So no matter what value of n we put in, we'd always get the answer 2. That's not right. What we've got to do is change this. Somehow this has to be added to a value. We need this value to be higher. Now if we think of how this program's working, we're not actually evaluating or using this input at all. What I've done now is I've added something. I've added this. I've added some assignment whereby answer needs to be given a value in this lower section of the if statement. So we're doing the equivalent of this. If you think logically, answer is the variable we've created that we want this function to return. Whether it's recursive or iterative, that's the kind of structure we want. So in both paths of the selection structure, we need to give answer a value. That wasn't happening in this lower half. Let me just get rid of the annotation. So now let's trace it through again. So with n equals 2, the Boolean expression's false, we jump down to here. So answer is going to equal a recursive call of the procedure again. This time 2 minus 1, it calls it with 1. Does n equal 1? Yes, it does. Then answer's 2. If statement's ended, jump down to here. I now return. I return from where the procedure was called. Now it's not actually a procedure, this is a function. And one of the things the exam board needs you to know is the difference between functions and procedures. Functions return a value. So this call of the function here will be replaced. This will be replaced by this. And this equates to 2. So answer set equal to 2. Now, we don't want this to return 2. We called the function with the value 2. We don't want it to return the number 2. We want it to return the answer 4. Now, at this level, n is 2. So if I take 2 added to what's come back, I'd get the right answer. Now, will that work for all values? Let's see. So what we've now done is just add n plus. And we're thinking, right, will that work? So now, if I call it with the value 2, that's false. We know this now calls the function again. n minus 1 means it's now called with the value 1. 1's a special case. Answer's given a value 2. Comes down to here. It returns answer. This is replaced with the number 2. So answer's set equal to n, which is this 2, plus the 2 from the recursive call. So answer's 4. That works. Now, will it work if we use a higher value? Let's see. If we call the function with the value 3, this is false. The procedure's called again here, this time with the value 2. Now with the value 2, this is false. Let's take this annotation off. Now we're getting exciting because we're going to call the function again. This is false. The function's called again here. This time it's called with the value 1. Now 1's a special case. That ends the execution. We're not going to go any further, any lower down. So we're at 3 levels of recursion now. If n is 1, answer's 2, it returns 2. This goes back to here. This becomes a 2. 2's added to n. What's n? Here, n is 2. Answer becomes 4. 2 plus 2 is 4. This returns the value 4. 4 is put into here. 4. 4's added to n. What's n? 3. 3 plus 4 is 7. Answer returns 7. I think we've done it. 3 maps to 7. And you can probably see if you carry on, job done. We've worked it out.